Okay, today I'm gonna present a paper entitled Modeling Tidal Bore Generation at the Estuary of Rokan River, Indonesia, authored by me, my colleague, and also my professor from the University of Ryukyu, Japan. And I will present it in the Increase Symposium 2021. Let's get started with the introduction. The unique tidal bore hydrodynamic process in the Rokan estuary needs to be revealed because the tidal bore data and documentation in Indonesia are tremendously minimal, and it is potential as a marine tourism for long distance surfing and fishery resource. The left panel shows the propagation of tidal bore in Rokan River, documented by the local people. And the novelty of this research, we are the first to report a model-based features of tidal bore generation at the Rokan estuary, and the tidal generated bore, the water level change during the propagation of tidal bore collision, and transport mechanism will be elucidated. Let's move to the methodology. First, we downloaded the data from 20 years data from 2000 up to 2020 from Geospatial Information Agency of Indonesia, or we can call it BIG. And the secondary data consists of coastline digitation retrieved from Google Earth image and also water level data from River Agency of Sumatra 3. And the right panel shows the research location. We will focus on the first in the estuary when the behind the Perdamaran Island and also the area of tidal bore decay. First, we did a tidal data analysis and modeling using now 99B model and Earth programs. Then we also simulated the numerical modeling based on shallow water equation. And also we determined the Rokan estuary morphology and a little bit spatial mapping and analysis in the end for layouting the result. This is the tidal harmonic analysis at the Rokan estuary. We can see that the Rokan estuary is predominated by semidiurnal tidal constituent. So the tidal type is mixed tide prevailing semidiurnal. Interestingly, the M2 is going to complete the tidal ring cycle very sooner because the pace lag value of this M2 is very high, and the overtides component are very low, showing by the M4 and MS4 constituent, the value is very low. And the below panel shows the spatial distribution of M2 magnitude and also S2 magnitude, and the misalignment pattern of both primary tidal constituents are shown by the red and blue dashed line. From this figure, we can see that the influence of semidiurnal components from the southern Malacca Strait on evoking tidal amplitude is observed, and the effect of semidiurnal constituents tend to get decayed upstream. This is the result of tidal ring analysis because the tidal ring is related to the generation of tidal bore. The higher the ring of tidal in the estuary, so the higher the tidal bore height propagating upstream. And we divided the phase of tidal: first the new moon phase, first quarter, full moon phase, and third quarter. During the first the new moon phase, the tidal ring range from 3.5 up to 5 meters, and with the duration ranging from 5 up to 7 hours. And the lower result is observed during the first quarter phase. The tidal ring is between 1.5 up to 3.5 meters, and with the duration ranging from 5 up to 8 hours. And the the characteristic also different during the full moon phase. The tidal ring ranging between 3 up to 4.2 meters with the duration 6 up to 7 hours. And during the third quarter, the tidal ring range from 1 up to 4 meters with the duration 5 up to 8 hours. From this analysis, we know that during the neap tidal phase, the duration is higher, but the tidal ring is lower. This is the validation of hydrodynamic model we use. The error obtained is 74%, and the below panel shows the surface elevation reflecting tidal bore height observed at R1, R2, and R3 station. The tidal bore height at station R1 range from 0.6 up to 1.2 meters, station R2 0.1 up to 0.4 meters, and station R3 0.05 up to 0.2 meters respectively. The height lowered by around 1 meters within the distance of 41 kilometers. This is the simulated water level after the passage of tidal bore. The water level after the passage of tidal bore ranges from 0.2 up to 1.2 meters. The water level increases within the channel where the tidal collision takes place. A shoaling effect increases the water level in the area with the significant morphological alteration. This is the features of tidal bore propagation and also identification of tidal bore collisions. The celerity of annular bore in Rokan Estuary ranges from 0.09 up to 0.8 meter per second, and the tidal bore collision is detected within the Berke and Perdamaran channels, resulting in declined celerity due to the collision event. The tidal bore commences decaying at station R3, and the presence of sandbank in the middle of the river indicate the high sediment settling transported by annular bore from downstream provenance. This is the transport mechanism of tidal bore, previously described by Jensen 2003, and this is the modification. During the propagation of annular bore, the score event takes place beneath the first wave crest. The suspended sediment is going to be transported along the tidal bore tracking area. When the tidal bore commences decaying, the transported sediment is settled in the bottom of water. It is predicted that the collision of tidal bore in the Berke and Perdamaran channels will induce a higher concentration of suspended sediment and settling event. Okay, this is the conclusion of this research. First, Rokan Estuary is predominated by semidiurnal constituent, which is M2 and S2, which plays a role in triggering the annular bore. Second, a sufficiently high tidal ring and shallow bed morphology induce a higher trend of bores. Third, tidal bore generated in the estuary propagated upstream, which the height is gradually declined as the bore reaches its decay area. This state also applies to the decreasing celerity toward upstream due to the shoaling, bottom shear stress, and morphology alteration. The last conclusion is in the Berke and Perdamaran channels, the collision between the delayed positive upstream surge and the backward bore take place, potentially triggering the higher sediment accumulation and silting. Okay, this is the end of my presentation. Thank you for your attention and have a nice day.